I got a comment the other day about calibrating the rangefinder, and this part is one of the trickiest parts in these Soviet cameras, or actually in rangefinder cameras in general. Um, so I thought I would try to make a video explaining the basic principle and what I do to calibrate the rangefinders. Um, it's not the most professional method, let's say, because I lack some tools like a lens collimator, but I will try to make do with what I've got. So, in my case, actually no, let's start somewhat different. When adjusting these cameras, there are a couple of aspects that need to be taken into consideration. You have the working distance, which is the distance from the lens mount to the film plane being the plane across these two rails. So obviously the film sits on these rails, the pressure plate pushes the film down, and there's a caveat here that I hope I won't forget to talk about a bit later, and it's something that I personally don't take into consideration for the time being because I'm still calibrating my process. Alright, so this is the working distance. For this mount, so the Leica thread mount, or M39 or L39, the working distance is 28.80 millimeters. So working distance 28.80 millimeters. All right, and we also have an acceptable error or tolerance, which is plus minus 0.002 millimeters. In some places I found 0.03, but even in Meisenberg's book on the Russian cameras, it's quoted being 0.02, so it's extremely small. It pretty much means that you need to be somewhere between 28.78 and 28.82, which is very difficult to achieve, and we'll get to that in a moment. Okay, so in order to measure and adjust this working distance, the adjustment is being done with the shims that you find under the lens mount. Now, unfortunately, I found 4 or 5 cameras so far in my limited 1 year and something experience that had no shims, and no shims can mean two things. One, that the distance is already equal or greater to 28.8, so anything added extra will increase that distance even more. And the second, somebody already worked on the camera and left the shims out. Okay. So you want to measure this distance. In order to measure the distance, you need something like this. This is a depth caliper. It basically has this support that is machined and is super straight, that will rest against the lens mount. Usually these gauges come with different supports. I don't know how they are called. Anyhow, so this is like, I don't know, 10 centimeters, although it looks a bit small for 10, but I'm going to measure it for academical purposes. So no, it's 6. This one is 6 centimeters, and there was another one for the same in-size model with a 10 centimeter foot. Let's call it a foot. I chose the 6 centimeters one because The other one, I thought it would be a bit too long and would hit against various things, so that's why I chose this one. Sometimes I regret the decision, but it is what it is. Now this one, it comes in a kit. It has different lengths for this rod, so you can unscrew this end of the rod and screw like an extender for maybe an M42 mount. Although I don't know by heart what the working distance is, it might work like this one. I mean, with the short rod. The idea is that for this mount, for the LTM mount, a 30 millimeter rod is enough. So you have 30 millimeters from here to here, if I remember correctly. All right, and what you do, you simply you need to calibrate it first. So your calibration is done by placing it down on a very flat surface, and then by turning this dial until the needle is pointing to 0, or better said, the 0 is pointing to the needle, because the needle obviously does not move when the caliper is seated down. All right, and 28.8 means something like this. This is 28.8, and the little dial reads 1 above 0, because it actually measures going backwards. So 1 to the right of the 0 mark means 29, and for 29.0 the big needle would read 0, and if it goes this way it means the distance is smaller than 29, so it will be 28.80. So this is where I need to be. All right. Now, in the case of the FED, so this is the FED 2, I need to measure the working distance against the film pressure plate. Obviously, this is true for all cameras, but in the case of the FED 2, I have a detachable back. You can measure against the pressure plate, or you can measure against a film strip that's put in its normal position with the back on top. I prefer to do it with the film strip, for the simple reason that when I'm taking pictures I have a film inside. It should not matter in theory, since without the film the pressure plate will sit against the rails, but this tolerance, so this error of 0.02 millimeters, is so small that any kind of imperfection will be read by the caliper and it will be interpreted correctly or falsely. Now, one of these imperfections could be a very slight bend in the pressure plate. So measuring directly on the pressure plate means that you will register any kind of small irregularity, and that is not good, because the film, maybe it's pressured down or pushed down against the pressure or against the film rails in a couple of spots. But since it is a physical object, a solid object, maybe all of its surface will be flat, even if, let's say, right in the middle the pressure plate is not actually pressing down on the film, if that makes any kind of sense. Okay, now the next problem could arise from the springs that push the pressure plate against the film rails. If the total pressure exerted by these springs is lower than the pressure that this spring exerts, that means the needle, the pin, will push down on the pressure plate, and you will get a larger reading than the actual value or the actual distance. And that is a big problem, because you obviously you start with a wrong premises, and you will inevitably reach a wrong conclusion. Now, in order to circumvent this potential issue, I use like a cotton pad like this, or a piece of that I have it stuck behind the pressure plate, so I actually increase the resistance against pressing down. Okay, and in my particular case, I have a dummy film. Let's call it a dummy film. All right, I will just stick it in here. Okay, and let's take it another notch. Okay, film is in, back cover is on, and shutter is open. Okay, and now it's pretty sturdy. Now the film, and this is the caveat that I was talking about, will have the tendency to bend inwards, or to bend towards this part of the camera. So inwards means actually forwards. Okay, now how much will it bend? It is accepted, or it was accepted by the Soviets, I suppose. At least it's mentioned like this. It's mentioned in the Meisenberg's book that the film will bend, depending on camera, between 0.01 and 0.03 millimeters, I think. And I will, let me see if I can find this information so I do not quote it incorrectly. Okay, so it says like this: currently the accepted film band in the FED and Zorki camera types is equal to 0.03 to 0.05 millimeters, and the 0.01 to 0.03 millimeter film band is considered acceptable in the Zorki 3 and Kiev camera types. So nothing about the FED. It does mention Zorki or FED camera types, but Zorki or FED camera types in Meisenberg means this. So pretty much Zorki 1, FED 1 types of camera. Since it says that Zorki or FED cameras have that greater tolerance, that it was 0.03 to 0.05, right? And then it says Zorki 3 and Kiev cameras that have a 0.01 to 0.03, if I remember correctly. The difference between, so this is Z1 and this is Z3, Zorki 1, Zorki 3. The difference between the two cameras is the fact that Zorki 3 and Kiev cameras have a detachable back, while Zorki 1s and FED 1s don't. Zorki 5 doesn't, Zorki 2 doesn't, but they are pretty much the only cameras that have that are bottom loaders. All right, so since this camera that has a lower film band is actually a back removing camera or normal loading camera, it means that the FED 2 should be somewhere here. Also, what this film band means, well, it means that you need to take into the consideration the band and actually use or calibrate for a larger working distance. So you actually want 28.8 millimeters from lens mount to film plane, so to the actual surface of the film. Now if the film is already bending or protruding a bit inside the film chamber, it means that you need to add this to that. So you will get a normal or correct working distance of about 28.83, 81 to 83, which is kind of fucked up anyhow. All right, let's get past this little issue. It's something that you not necessarily need to keep in mind or consider, but no, it's something that you should consider. It's not something that you need to act on, but you should consider it. All right, so now if I put my depth caliper and I'm pointing the tip right on the middle of the film gate, of the film opening, my caliper reads exactly 28.8 because I did not care about this. So but even with this film bend taken into consideration, it's still okay, because let's assume 0.01, add it to that 28.8, I'm still within these 0.02 millimeters from the nominal working value. All right, if I move, so this is the central point. If I move the caliper to this top left corner, and I'm trying not to, okay, it seems steady. 28.81, so I'm good. On top left, 28.81. On bottom left, I'm short. Bottom left says 28.76, so I'm out of spec either way, but I don't care. I don't care, because if I raise the bottom left, which is actually the bottom right, don't mind me, if I raise the bottom right, everything will change. Maybe these two or these two won't change, or at least this one won't change because it's opposite, but the central point will certainly change. Now, if I could raise this point, this bottom right, by 0.04, which is possible because this is a piece of Teflon tape. Now I use the Teflon tape, it's like the one you put in the oven with the food or whatever when you cook the food. If I use the Teflon, I use the Teflon tape to glue things. So I put it like under the curtains when I'm applying the glue, so it won't make a mess on the rubber mat. Anyhow, so this is 0, and this is, oh, I don't know why I remembered it was thinner, but it's 0.07. So basically you need something that's even thinner than this, which might be a problem. I don't think I have something that thin. Well, that means it is what it is. And bottom left is 28.79. Okay, anyhow, by all standards, I assume this is as good as it gets. You might get lucky and have a camera that you can adjust to be perfectly straight at 28.8. I haven't had the chance so far, so I've always had a very little, let's say, misalignment. Okay, now once you have this setting correctly adjusted, you will also need to make sure the lens is correctly adjusted. So the working distance of the lens corresponds to the working distance of the camera. Obviously, ideally, you need to adjust any kind of camera body to the correct working distance, so you have the certainty that any lens that's correctly calibrated will work on that body. Now, to adjust the lens, that is, I think, a lot trickier without the proper tools, so without the lens collimator. But each lens should have somewhere either some adjustment screws, or in the case of these cameras, a shim or multiple shims. So this shim, which is quite thick, will take the optical block to the correct distance from the lens mount. And obviously you can adjust the working distance by using various materials. One of those materials is this. This was cut for Helios, all right, for Helios. It was cut from a cardboard box used in food delivery. So you order food on the go, and most likely it will come in a box made out of a very thin cardboard. If the cardboard doesn't get stained by the food, you can cut shims from it, and you can cut the shims with a special, I don't know where it is. Yeah, it's not here. It's like a compass, but it has a cutting. Instead of two pointy feet, it has a blade. So you stick it and you turn it and it will cut round things. All right. If you don't have the means to collimate the lens, like I don't, you can still check the lens. Why is it a bit rough here? Anyhow, in order to check the lens, you will need the calibrated body, you will need the lens, whatever lens it is, and you will need a ground glass. Now you can make do with I don't know how it's called, magic tape, something like that, from Scotch or 3M. It's like Scotch tape that is frosty, so you can't see through it, and it's very thin. In my experience, yes, you can use that measure, that material or that method, but it's not really what it's supposed to be. In my case, I will use a focusing screen. Now this is a focusing screen that I stole from a Praktica camera that was totally busted, so I suppose it still lives in this setup. So it's a regular focusing screen that has a split screen in the middle, and what's funny about it is the fact that it has a double split screen. So it's a little circle with two bands, or a band in the middle, so two halves divided by a band. So you will get 2 points where you need to align the lines in order to be in focus. Anyhow, you can use any kind of focusing screen. The split screens ones are easier to use, obviously, because you have the certainty when you are in focus. And you need to place this focusing screen on the film rails. Now on the FED 2, that's very easy, because most cameras, they have a set of rails. So two inner rails are for the actual film and are a bit lower, and another set of rails that are a bit higher. Higher means more towards the back of the camera. I'm not really sure why, I never really thought about it, it doesn't matter. But the idea is that you need to place the focusing screen on the inner rails. So that's very important, on the inner rails, and obviously you can't put it like like this, so long edge vertically, because you will place the focusing screen on the outer rails, and that's not good. In the case of the FED2, that is perfectly fine because there's only one rail on the bottom and one rail on the top. So I just put the edge of the focusing screen flush to this protruding part of the body, and the bottom of the focusing screen will just sit wherever it wants, because the actual focusing screen is now resting against the rails. Okay, and I'm just taping it down and making sure it's not wobbly. Now, the focusing screen has two sides. One is more matte and the other one is more shiny, let's say. Shiny side outwards, so matte side towards the film, because that is the surface where the image forms, and obviously you need to have the image forming surface where the actual image would form on the actual film, and since the film goes emulsion down, you will have to have the frosty side of the focusing screen down. Alright, and now what you do, take the lens, mount it on the camera, focus the lens at infinity, and then use a loop. I have this optical block from a Pancolar lens that I destroyed a long time ago, and I'm now using as a magnification aid. Take the camera, get the shutter open, keep it open, either by locking it open if you can, or by using a shutter release. Set the aperture to the widest possible, f2 in this case, so f2, lens set to infinity, point the camera to a very distant object, ideally like something like the moon. If you don't have the moon, maybe you have something like a couple 100 meters away, and look on the focusing screen, and you should see the image in focus. If the image is not in focus, it means the lens is not calibrated correctly, as long as you are totally certain that the camera is. Okay, so that's very important. If the lens is not in focus or it's not calibrated, then you need to calibrate it. And in the case of the Jupiter, it's not that difficult. If the lens goes beyond infinity, so you get the two halves of the image, right? So you are focusing on that very distant object. At some point the halves align, but the focusing ring on the lens can still move further. So you focus it further, and the two halves are not aligned again. So you are practically, you have focused to infinity and beyond. In that case, it means that the lens goes, or the optical block goes two-way towards the camera. Not two-way, Jesus, too much towards the camera. And that means that you don't have enough shims. So it's a matter of adding. If you cannot focus at infinity, so you are stopping short, it means you have too many shims, or a shim that's too thick. And by trial and error you can correct for this problem. It's not easy at all, but it's doable. Now, Meisenberg's book describes a method in which you can do this a lot more predictably and more easily, meaning that you can actually determine the thickness of the shims. So when you know that you need like, I don't know, 0.5 millimeters worth of shims, you can create 0.5 millimeters worth of shims. It's a lot easier than only knowing that you need a little bit more or a little bit less without knowing how much more or how much less. All right, so this is the way you can adjust the working distance on the body mainly, but also on the lens. Now on a lens like this, a collapsible Industar, that's a lot more trickier to do because that shim is between, obviously, the lens block and the rest of the body. Now the lens block is kept in position inside the body by means of a retainer ring here, so you don't just unscrew it, and also by means of this little guy that keeps the optical block in a certain relation in respect to the outer bezel here that has the aperture marks. So if you don't put it in the correct position, the aperture ring will no longer align with the aperture marks. Usually it will be 180 degrees to the other side. So you need to, if you need to go back and forth a lot of times with the thickness of the shims, each try will mean removing the screw, removing the retainer, getting this out, replacing the shims, putting everything back, making sure everything is in the correct position. That will be, I don't even want to think about it, and I should, because I've got 3 lenses that I need to service, and one, I think, this one, I think, is totally off. So it doesn't reach infinity. So there's too much of a shim here. Anyhow, that's something to worry another time. Okay, now before getting to the adjustment, the same adjustment on this camera, which is a bit trickier, I will try to cover the actual rangefinder adjustment, which is the easiest and it must be done first. So this whole focusing and rangefinder adjustment charade can be divided into 2 parts. The actual rangefinder adjustment and the actual working distance adjustment. So there are 2 different things and both need to be correct in order for everything to work, because what you see in the viewfinder is not what the film sees. It should be, but it's not, and your job is to make them coincide. Okay, so adjusting the rangefinder is as easy as adjusting a screw that you will find in this hole in the FED 2, respectively this hole, so behind this screw in the Zorki 1, and a very small shallow prism that is this lens. So it's basically, it's not a lens, it's a piece of clear glass, I think, that is not, that doesn't have 2 straight surfaces, but they are slightly tilted, one in respect to the other. So when you are turning that lens, this is the section of the lens, what I'm showing you now, when you are tilting it, you are actually moving the image up and down. So in order to adjust for the vertical, you need to turn this inner ring. So this is what turns the actual lens. And in order to adjust for the horizontal, you need to turn the little screw that's inside here, and that screw will move the rangefinder arm more towards the back or the front of the camera. Okay, so this is not complicated. It's super easy. What is complicated is adjusting for close focusing, which is a major problem with these cameras, and you run the risk of getting your film back from developing, either somewhere else or in your own bathroom, and realizing that you have missed the focusing on all those portrait shots that you tried. So every time you will see the focus is on the back of the head or in front of the head, and adjusting for that is a lot more tricky, especially in this one. In this one is a nightmare. In this one is a bit easier. So the name of the game or the trick is the shape of this little arm. So if you there are different shapes to these rangefinder arms. This is one of the shapes, so it's like the, I don't know, the end of a spearhead. Okay, and this is more like an axe. Yeah, they actually look like a spearhead and an axe. Why is one in one way and one in the other way? I don't know, and I don't care. It's something that they did. I think they had like 4 different designs of this rangefinder, I don't know, sensors or whatever you want to call them. But the idea is the same across the design variations, and the idea is that little cam, let's say in the case of the Zorki 1, it looks something like this. Okay. And it has a pivoting point like something like here. Now obviously, since this point is not the geometrical center of this thing, when you tilt the cam, it's a cam, so when you tilt it, this tip of the cam, so this little bit here, will move up and down, right? Because it's not like a circle. Since it's a cam, it will move up and down. Now that tip, or this part, is what actually reads the position of the lens. So it sits here on the lens, and when you focus the lens, it will push the whole arm in or out. Okay. So you have a rangefinder arm let me see if this one writes better. Okay, so this is the rangefinder arm that controls the little mirror inside the 45 degrees mirror that takes the image from here, and so the image goes here, it bounces against that 45 degrees mirror and goes here, where it bounces another mirror that's a half mirror, a beam splitter, and it goes towards your eye. That's how you focus the image. Okay, so on one hand, pushing, turning that little screw will adjust the position of the overall position of this arm, because you have a screw like let's say here, and this is the pivoting point, and when you turn in the screw, you will push the entire arm like this, so away from the front of the camera. When you turn the screw the other way, you will let it go further out. and that's the adjustment for the infinity position. Now, to adjust for close focusing, you need to turn this, so the cam, just the cam, out or in, or better said, away or towards the rangefinder arm. And to do that, you will need a good subject, something at a closer distance, like, I don't know, 1.5 meters, let's say, or 2 meters or 3 meters. You will get your lens. Where is my lens? Okay, so you'll get your lens. You have the rangefinder calibrated for infinity. You have the lens checked, so the lens focuses correctly on when set to infinity on the ground glass. You have the working distance measured and it's correct, and now you need to check for close focusing. So you will put your camera down, you will focus the lens looking in the viewfinder until the image is in focus on that subject that is, like, let's say 3 and something meters away. And then you will take your loupe and look on the ground glass that is still attached to the rails, and you will most likely see a difference. And if you see a difference, well, good luck to you then. If you see a difference, continue focusing the lens while looking through the loupe on the ground glass until you are in focus. Now let's say that initially by looking in the viewfinder, my subject was focused at 3 meters. If when looking on the ground glass, my subject is focused like this, so beyond 3 meters, then that means, if I remember correctly, that I need to turn the cam away from the arm, so like this. So basically putting the tip of the cam away from the arm. And you should do that in very, very, very small increments, something like 3 to 5 degrees of an arc, of a circle. Okay, after you've done that, you will need to recheck infinity, and you'll need to readjust, most likely, that little screw for the horizontal for the infinity position. Then you'll need to go back to this one, to the close range adjustment, and back and forth until you get correct focusing on the infinity, correct focusing on close distance subjects. And obviously it takes a lot of patience and probably a lot of time, because after looking through this and through this for a couple of minutes, your eyes will start getting tired, and you will no longer have the accuracy, the vision accuracy needed to complete the task, especially since this viewfinder is very, very, very small, and that is making things a lot more difficult. But that is the way to actually adjust everything in the FED 2. Now, to adjust everything in the Zorki 1, I am using the FED 2. Because on one hand, the rangefinder base is so large, so long, that the camera should be extremely accurate when focusing. So moving like the most minute amount of the focusing ring will actually be very visible in the viewfinder. So the double patch will be totally off. Okay, so how do I do it on my Zorki 1? Obviously, what I'm going to tell you now is not applicable to you if you don't have a FED 2. But if you don't have a FED 2 and you have a Zorki 1 or a Russian Soviet rangefinder, do get the FED 2. It's a great camera, actually. And why not? The more the merrier. Okay, so how do I do it on the Zorki 1? Well, on one hand, obviously, I need to set the working distance. And to set the working distance, I need to go through the same steps as mentioned before. This one says 28.78 in the middle with no film. If I'm putting this piece of film says 28.795, so pretty much 28.8. And it says 28.82 and 28.82, 28.79 and 28.82. So it's within the correct, come on. Oh, you can lock it. Great. It's within the correct working distance. Now, once I have the working distance set correctly, the next step is to adjust the rangefinder. Now, adjusting the rangefinder is already discussed. It's nothing different. Vertical, horizontal. Obviously, you adjust the rangefinder for infinity. And that means having a lens set to infinity on this body. And I will use the same lens that I use on my FED, because for the time being the two are making a very good pair. Okay, so lens set to infinity, adjust rangefinder. Then I will put the camera in the exact same place where my FED was when calibrating for close focusing. And I will know that for that subject, this lens should be at some value when the subject is in focus on my focusing screen. Okay? And then I will focus the camera on that subject and see where the focusing ring falls. In my case, if you, maybe you can see it, maybe not, there is a very fine black line here between 3 and 4. That's my reference point. So this is where the lens is for my setup. It's a marker, a permanent marker line that I will eventually clean. Okay, if when focusing the camera, let's say my mark on the lens is at 4, I will need to rotate the cam away. If it's like at 3, I need to rotate it inwards, and obviously go back and forth between this and the infinity setting. And eventually, when the two will coincide, meaning that both close focus and infinity are correct, this line for close focusing and what I see in the viewfinder for infinity, obviously lens must be set to infinity, then I can say the camera is adjusted. And then I can test it with film. Now these cameras came bundled with these lenses, the Industars 10 and then Industars 22, and maybe some came with the Jupiter 8, but I'm not really sure about that. On one hand, this is the correct lens for this camera point. not point, point is in Romanian, full stop, full stop. So that's an exclamation mark. There's no way anybody can convince me otherwise. Because it's super small, super pocketable, literally you can put this in a pocket. And some will say, oh no, this is a crap lens, it's 3.5, it's a very nice lens, it's super sharp, it's all you need. Being a 3.5 lens will forgive you if you have very small errors in setting the camera. If you shoot it, I don't know, street style, so you will shoot it at let's say f8, f11, f16 even, I don't know, it will forgive you for even more error. If you are trying to shoot it wide open, not so much. If you try to shoot a Jupiter 8 wide open, it's most likely going to be a mess, because on one hand the depth of field is so shallow that you need to be spot on with your adjustments, and that is very difficult to achieve. On the other hand, the Jupiter 8 is soft wide open. You might get the impression that you are out of focus when in fact the lens is just soft. Okay, I think this is it. So I've covered rangefinder adjustment, lens adjustment, working distance adjustment into different cameras, ground glass, rangefinder arm. Yeah, I think I'm done. It's probably a very long video already, but I know some people are interested. Some actually expressed this interest, and it's a very spiky, spiny, difficult subject when it comes to adjusting these cameras. But yeah, it can be done, and it does require a limited amount of tools, meaning this one, and maybe a normal caliper that has a good resolution and accuracy. And this kind of depth gauge, it's not cheap. It's not cheap. Maybe it's not worth it for you if you have one camera to work on or something like that. If you, like me, get into this hobby of working on and fixing a larger amount or number of cameras, then this is a very good investment. It's $100 and something probably. You can go way higher in costs for it, but it really does the job. It really does the job, and it's very important, because you can never trust the measurements that were done before, by the factory or not, unless you are working on a Leica. Because if you are working on a Leica, and the Leica hasn't been messed up before by somebody else, you will get 28.8. It says 28.9, but I remember I adjusted this one, not adjusted, I checked this one, and I was surprised how accurate it was. Maybe I don't remember correctly. Anyhow, if the camera was factory adjusted and hasn't been messed with since, it should be probably close to perfect. Oh yeah, one more thing and I will leave you alone. If you have a shiny pressure plate like this one, now this is shiny because before I kind of polished it which is something very controversial, and many will run like they've seen the devil. Let me... okay. So before I polished the pressure plate, it was like extremely rough. It would have been a total disaster for a film. So I had no other option. This one, see, it's like dull. It has a very dull finish, but it's super smooth. I don't know how they did that. Or better said, I don't know how I could do that, how I could get that finish on this pressure plate. I haven't seen any ill effects when using this camera or any other camera. This one is super shiny as well. And they are all super shiny because they are all fucked up when I start working on them. Let me see. This one had like a ton of super deep scratches, but this one is like a mirror finish here, so it's out of the question. Maybe I'll try to find a way of dulling that surface, but anyway, you can use the actual shine of the pressure plate and the laser beam to actually make sure that your depth caliper is not pushing down on the pressure plate. You can, or you can even do it by eye. So I have a couple of light sources above me, so I see the shine of the light source in the pressure plate. Probably you can see it too in the video. Now, from my angle of view, if I put down slowly the depth gauge, if it pushes down, the reflection of the light will shift. Obviously, it would be a lot more precise if I could shine a laser beam, like a pointer, a red dot pointer or something. I would shine it down on the pressure plate from an angle, and the laser beam like being held in a very precise position. And the reflection of that beam would be somewhere inside the camera, somewhere where I can see it. And then I would come with my depth caliper and see if that reflection, if that red point moves or not. Just a thought, just a thought. I use my own method, so cotton pad in this one, double springs under the pressure plate in these cameras. So I have another set of springs. I will double them under the pressure plate, make my measurements, calibrate my lens mount, take it all apart again, remove that extra set, and now I have my working distance, I have my set of shims prepared, and it's done. See, like this. Okay, thank you for your patience. I hope it has been a good video, a good topic. I know I haven't spoken so much in a very long time because my throat is dry. Yeah, I hope it will help someone, whoever wants to adjust their cameras as good as possible, and I hope I have answered your questions, if this was one of those questions. Alright, thanks again. I will see you next time, and we'll see what we'll talk about. Good night.